All right, so here is what we're going to start doing today. We may finish it, we may not. We're right on schedule where we need to be. So we'll get to as much of this as we can today. Solving quadratic equations. Solve always means get x by itself. In this particular case, we're solving quadratics. So long as you're getting the variable by itself, that's what we're looking to do. In this particular case, when it says solving quadratic equations, you're getting x by itself. Your goal is to solve and get x by itself. And we're going to show you how to do it multiple methods. So how many methods do we have to show you how to do this? 5. Now, when it comes to how you do it on a test, I don't care what method you use as long as it makes you happy. So if you got 5 methods and you like this one, whichever method better, wonderful. However, there is a however. All the methods don't work with everything. So you can't do the square root method with everything. You can't do the factoring / swing and divide method with everything. The only one that works with everything is number 4, the quadratic formula. That method works for every quadratic equation that you want to solve. The other ones, you got to decide whether or not you're going to use those. So with that said, let's look at this slide. So first thing you're going to do is set the equation equal to 0. So you can solve and get x by itself. You always have to have a 0 on the right side. What if they give you an equation that don't have a 0 on the right side already? What you going to do? You're going to add a 0? And what else? What else you going to do? So for example, what if your equation looks like this? What if you have your quadratic equation is 3x squared plus 5x equals -6. Aha! What you gonna do, because you gotta have a 0 on the right. No matter what you do, you gotta end up with a 0 on the right. Add 6 to both sides. So it's gonna assume that you know to do that. To go back and put it in standard form, put a 0 on the right. So now we will go here and add 6 to this side, add 6 to this side of the equation. And so I end up with 3x squared plus 5x plus 6 equals done. So just know that if they give you an equation and they don't have a 0 on the right side of the equal sign, you got to make it so it does. All right, questions? All right, so here is the next slide. We're going to do something called solving using right here where it says the even root, it means square root. I should have the word square root where it says even root. It should say square root. So, and it's got the different examples. So I'm going to show you each of these methods. The square root method is the one that we're going to do first. The square root method is the one that we're going to do first. So let me use the first example that you see here on the screen, and then I'll show you a different one. So square root method, we're going to do this one using the square root method. When do you use the square root method? When there's a missing middle term. I'm trying to see if I want to use that one. Nope, I'm not going to use that example. That was just to kind of give you a preview of what you're getting ready to do. We're going to use the square root method first. The goal when using the square root method is you're trying to get x squared on the left side by itself, and then end up with x by itself. But the goal first is to get x squared by itself, then get your x by itself. So here's the first 2 examples that we want to do. All right, so we're going to use the square root method. Now here's the question. When do you use the square root method? Well, look at this. It's got an x squared and then a number here. What's it missing? The b term. Remember, your standard quadratic is ax squared plus bx plus c. So it's got an ax squared. It's got a plus c or minus. It's got a -9. It's missing a middle term. So you want to use the square root method when it's missing the middle term. There's no something x, 6x or 5x or 10x or whatever. It's missing that middle term. You will always want to use the square root method when it's missing a middle term because it's easy that way. All right, so doing the first one that you see here, 4x squared minus 9 equals 0. What are we trying to get by itself first?
X squared.
X squared, okay. So I'm going to add 9 to both sides. The -9 and the +9 cancel out. So now on the left side of the equal sign, I have 4x squared is equal to 9. Divide both sides by 4. Okay. So x squared is now by itself, and it equals 9 over 4. Now, how do I get rid of this 2? See this 2 that I have as the exponent? Take the square root of both sides. So I'm going to take the square root of this side and the square root of that side. So I've got x squared in here, and this is 9 over 4. All right, when you take the square root of something squared, the x just falls outside of the square root symbol. So you end up with an x here, and your answer will always be a positive and a negative. So there's always going to be 2 answers. When you take the square root of both sides, you're always going to have 2 answers. One's going to be positive, one's going to be negative. When you type it in My Math Lab, it's not going to let you write it like this. So it's not going to let you put a plus and a minus on top of each other. So you're going to separate it into 2 separate answers. Well, first of all, tell me what's the square root of 9? 33. And what's the square root of 4? 2. There's my answer. Now you're going to have a positive answer, and you're going to have a negative answer. You should put a comma in between them. Those are your 2 solutions. When you solve that quadratic equation, how did I know it was a quadratic equation? The 4x squared minus 9. How did we know that was a quadratic equation? The highest exponent is a 2. So it's a quadratic equation. And it's missing a middle term. So when do you use the square root method? When it's missing a middle term. Missing a middle term. Middle. So it's missing a middle. So it's missing, what I circle here in blue, it's missing that piece right there. Missing a middle term. All righty. Let's do the next one. All right, you ready?
Yes.
All right, here's the next one over here. This one's actually, they don't have anything sitting next to the x squared. So I've got x squared minus 32 is equal to 0. I want to get x squared by itself. What should I do?
Plus 32.
Plus 32 on both sides. So I end up with a minus 32 plus 32 cancels out. I have x squared on the left is equal to 32. What now?
Square root.
Take the square root of both sides. Alrighty, so I've got x squared here and I got 32 here. So this is going to be a x. Let's put this in blue. There's my x is equal to a plus something and a minus something. Can I leave this answer like this and just put the square root of 32 like that? Can I leave it?
No.
No. You've got to remember your squares, perfect square numbers. You know what perfect square numbers are?
Yeah.
Because you got to decide, are there any perfect square numbers inside of 32? So you look at 32. So over here on your scratch paper, you would take 32 and say, what are all the numbers that multiply together to give me 32? Well, I know 1 and 32, 2 and 16. What's the next one? 4 and 8. Anything else? Okay? Those are all the combinations of numbers that multiply to give me 32. Out of these combination of numbers, which numbers do you see are perfect square numbers?
4.
Okay, 4 and 16 are your perfect square numbers. You always want to pick the biggest one. You always want to pick the biggest one. If you pick this one, do you have another 4 inside of here? Then you got to take a square root again. So you always want to pick the biggest one. So we're going to come over here and rewrite this as the square root of 16 times the square root of 2. Does it matter what order I put them in? No, I just like to put the one that's the perfect square first. Okay, so now I've got x is equal to, what's the square root of 16? 4. So now I've got 4. Whoops. All right, come on. Square root of 2. Now, that's your answer. This is time sign. You get rid of the time sign. And it should have a plus minus. So there is a negative one and a positive one. So your final answer is going to be a negative 4 square root of 2 and a positive 4 square root of 2. Those are your 2 answers, your 2 solutions. It's going to assume that you know to go do this right here, what we just did. It's going to assume that you know how to find what all the factors that multiply together to give you 32 or 76 or 95, whatever they give you, it's going to assume that you know how to go do that. Find the factors of the number and find the perfect squares. Does everybody know what I mean when I say perfect squares? Should I explain? Okay, perfect square numbers. 1 times 1 is 1. 2 times 2 is how much?
4.
3 times 3?
9.
9. 4 times 4? 16. 5 times 5?
25.
All the numbers over here on the right side of the equal sign are perfect square numbers. Their multiples, their factors are the same. Now you might say, well, why do they call them squares? They don't have nothing to do with no square. Of course they do. Well, look at this first one, of course, is just this one. Now let's look at this one. If I rewrite this, can I break this up into how many squares or how many columns do you see over here?
2.
1, 2. How many up here? 1, 2. So this is a 2 by 2 square. How many squares do you see all together?
4.
So you got 2 rows, 2 columns, 4 squares. Can I do the same thing with 3? Of course we can. How many rows, how many columns? 3 and 3. Do you see a square? Yeah. How many squares, little square boxes? 9. That's why they call these perfect squares. Because you can actually redraw them geometrically so that they actually look like those many little bitty squares, but the outside are going to be rows and columns that still multiply together. That's why they call them perfect square numbers. Okay, that was a side note. All right, so are we good with when do you use the square root method? When you're missing the middle term, the B term, and you've got to decide how to find the square root of a number that's not a perfect square already. If it's one of these numbers, it's already going to be a perfect square. But what if it's not? Then it's our job to make sure we break it down so that you can find the perfect square number inside of it. All righty, we're good? All righty, here is the next slide that we're going to do. We're going to do something called factoring. Factoring requires that you know your multiplication tables. Do you remember most of them? Some of them? Most of them. Okay, so as long as you know your multiplication tables, we can do this. I know you can't read the verbiage. No need to read the verbiage because I'm going to explain this. Sometimes when you see it written mathematically in the math verbiage, it still may not make sense because you got all these letters of the alphabet, these variables in here. So let me help you make it make sense. We're going to be given a quadratic equation and we're going to do something called factoring. Here is the actual example that we're going to follow. All righty. Do I have a quadratic equation?
Yes.
Yes, okay. And now I'm going to step 1. Tell me what the factors of 18 are. That means you know your multiplication facts for 18. What are the numbers that multiply together to give you 18? 1 and 8. You can see that I wrote them here. 2 and 9 and 3 and 6. Okay? All right. So we got all the numbers that multiply, the combination of numbers that multiply to give me 18. You've got to tell me, out of these combinations, which two add up to be the middle number 11? 2 and 9. So it's that the two numbers that you pick got to multiply together to give you 18, but they got to add up to be 11. You always are going to be adding up to be the middle number. So they multiply to give you the right number, add to give you the middle number. We're good? So whichever two numbers you pick, now let me say this part. I've got what kind of 18? A positive 18? Mm-hmm. So this is a positive 1 and a positive 18. This is a positive 2 and a positive 9. A positive 3 and a positive 6. Because I've had some other combination of numbers that you don't see on the board. What other numbers? There's some other ones that we didn't put. What? Negative 1 and negative 18 times negative 1 is still positive 18, right? What about negative 2 and negative 9? And what about negative 3 and negative 6? Now, again, I'm saying this because you're going to run across a problem where you're going to need some of these negative numbers. So these weren't all the combinations of numbers. You had 3 more that you could have used. But now, they still have to, if you add them together, got to add up to be 11, positive 11. So out of the set, these two are the two that I'm going to pick. And you literally are going to put your plus 2 right here and your plus 9 right here. And automatically, because we're using x as the variable, you're automatically going to put an x here and an x here. This is called factoring. Now, once you do this part, so I literally take this number, you already got a plus 2, take this number, you already got a plus 2, and put them with an x behind, dispute with the x in front of them. So, once you're done with that, what's the next step? Set them equal to 0 and solve and get x by itself. So here we go. So I've got x plus 2 equals 0, and I've got x plus 9 equals 0. How do I get x by itself? Subtract 2 from both sides for this one. What should I get as my answer? Negative. X equals -2, and over here I'm going to subtract what? 9. Subtract 9 from both sides. What's going to be my solution?
X equals 9.
All right, so if I scroll the screen up just a teeny tiny bit, can you see your answers?
Yes.
There you go. Done. Those are the solutions. Now, what does that really say? It says if I plug in a -2 into the original equation, if I plug a -2 back in here, right here, see where, let me write it here so I'm not, my little line is not in. So if I plug a -2 in the place of that x and I plug a -2, so here, plus 11. Now, what does this say? If I plug a -2 into that original equation, what's it going to equal? 0. Did we set this equal to 0 originally?
Yes.
All quadratic equations are set equal to 0. So you're going to start off with it like this. And then you're going to go do the math over here on your scratch paper. These get set equal to 0. So that's how I ended up setting each piece equal to 0. You start out, set it equal to 0, do your fraction, do your multiplication math over here, set these two equal to 0, then set them separately equal to 0, and solve and get x by itself. So what we're saying is if I plug a -2 in here, this better be equal to 0. Well, let's test it and see. What's -2 raised to the 2 power? Okay, so that's 4 plus, what's 11 times -2? -22, so this is going to be a -22. All right, somebody do the math for me. What's 4 minus 22? 18. -18, and what's -18 plus +18?
0.
Done. That's all you just figured out, is if I plug in a -2, this original equation equals 0. It also says if I plug in a 9, it will also equal 0. You got it? Okay?
I missed why did you use the -2 again? I missed that part.
Why did I plug in the -2?
Yeah, why did you plug the -2 back into the original equation?
To prove that it equals 0. So if I keep doing all the math here, it equals 0. So we're checking to see if it equals 0. If you didn't get the right answer, if you plug in the number, it won't equal 0. If you solved all of this and did all this math over here with your multiplication tables and you got x equal 5, if we plug in a 5, it ain't gonna equal 0.
So I could have plugged in a -9 and still got the 0 too?
Correct. These are the only two numbers that'll work. Those are your only two solutions that will make that equation equal to 0. Nothing else. Okay, so that's just how you check it to make sure that your answers are right. What you thinking?
Well, I guess I was thinking like, but if you take x plus 2 and x plus 9 and you multiply them together, and then the first term, middle term, outer term, and inner term, you get the same quadratic equation.
Correct. That is true. You do. If you say do what we call FOIL.
Yeah.
Yes. What
I
we call
guess that's
FOIL.
what I was remembering, the how to, not what it was called.
Right. So you're saying if I multiply this back together, I get this.
Yes.
That is correct. But does it tell me whether these two numbers work?
No.
No, but it does get you back to the original equation. That is correct. All righty. Questions? All right, well, let's try another one. Here's the next one, x squared minus 9x plus 14. We're going to do this one before we pull it up on the screen. X squared minus 9x plus 14, is that what I said? Okay, x squared minus 9x plus 14 equals 0. Solve that quadratic equation. See what you got. Y'all work. Go ahead. Your turn. What you going to do first?
Square root.
What method? Am I going to use the square root? This is called the factoring method that we just did. So, can I use the square root method on this one? Can I use the square? No, it's got a middle term. It's got to be missing. So, I got to do my factoring. So we gotta do factoring. So what should I do first? Find the factors of 14. So over here on your scratch paper somewhere, you should be telling me the factors of 14. So 14, and then some positive 14. What you got? What time's what?
14.
Okay, so positive, you tell me positive?
Yes.
Positive 1 and
Positive 14.
what else?
Positive 2 and positive 7.
Okay, what else?
Negative 1. And negative 4. Negative 2 and negative 7.
All right, out of those combinations of numbers, which two add up to be a negative 9?
2 and 7.
2 and 7, this one?
No, the one at the bottom.
The
No,
negative 2 and
negative 2
negative 2
and
and negative 7 add up to negative 9? I agree with you. So we add them together. So again, if we say add, and add. So the only two that add up to negative 9 is this one. All right, what I'm supposed to do next after I got those two numbers? I know what they are.
Set it, do it like that. So it's 0.
Okay, so you should immediately set parentheses. What should I put in the front of these parentheses?
X.
X's, whatever variable they use. Now take the exact numbers from the what we squared, what we put a box around,
Negative 2 and negative 7.
and
Negative 7.
okay, now what?
Set them to 0 by itself.
Set them equal to 0 each by themselves. And now you solve and get okay, x by itself. So what should I do? Add 2. Those are the solutions that make that statement equal to 0. And then we can plug them in to check them. So if you want to check it, you plug it back in. So if we plug in 7, this is 7. All right, so that's squared minus 9 plus 14. What's 7 times 7?
49.
49, okay.
X for number.
And then 9 times 7?
63.
That's 63 plus 14. All right, so I'm gonna do that in the calculator. That's the 49 minus 63, is that 14?
Yeah.
Yeah.
Yep. So this is a negative 14 plus a positive 14 equals 0. All right, checks. Okay, not so bad, right? What is this method called again? When can you use it? When should you use it?
When you don't have a middle term?
Okay.
No, that's
When you have a middle term and what else? You can tell that this number has factors that add up to be the middle number. You're gonna have some that don't work like that. So for example, let me give you one just right off the top of my head, making this up for a second. X squared plus 3x plus 19. What times what equals 19 but adds up to be 3? Nothing. So you cannot use the square root method, and you cannot use the factoring method. That's why you got 5 different methods, right? That's why we have 5. So that one will not work. So let's look at the next slide because it's the one we just did. Did we get that answer?
Yes.
Yes, we did. All right, here's another one. You ready? X squared minus 6x minus 16. X squared minus 6x minus 16. I need the numbers that multiply together. Can you? Well, let's see.
Yes.
That's the question. What are all the numbers that multiply together to give me negative 16? Okay, tell me some. Do you want a positive one? Positive 1 and negative 16. Okay. What else?
Positive 2, negative.
Positive 2 and
Negative 8.
okay. What else? 4 and 4. Which one? Positive 4 and negative 4. What else?
Negative 1 and positive 16.
Negative 1 and positive 16.
Negative 2 and positive
Negative 2 and positive 8. -4 and +4, we already, since these are already up here, we don't have to repeat those. So now, out of those combinations of factors, which one, if you add them up or subtract them, equals -6? I should say add.
Positive 2, negative
The second one or the last one?
The second one.
The second one, so we wanna choose this one. Alright, well, put your parentheses over here, this is the easy part, put your parentheses, so I'm gonna have what? X plus
2 and x minus 8.
Okay, set them equal to 0, that's the easy part. Can you always see that the answer's always gonna be the opposite of what this is? Okay, so if you decide, well, I don't wanna do that extra work of subtracting 2 from both sides, that's up to you. It's just making sure you see it clearly, that the answer's always gonna be the opposite of what you have right here. So that's gonna be x equals 2, and x equals -2, and x equals +8. Questions? Alrighty, so that was for the next slide. I just wanted to be able to see if we could do it by ourselves before we pop it up on the screen. There it is on the screen. Did we get the same solution?
Yes.
Yes, we did.
That's the same method?
Same method.
Yeah.
Same method. What is this method called?
Factoring.
Factoring. We're factoring. It's calling it factoring because we are looking for the factors of 14 or 16 or 18. We're looking for the factors. So that's why they call it factors. Factoring. All right, you ready? Let me see. All righty, here we go. This is the next one. I'm trying to see if this is the one that I want to do. Yeah. All right, so here's another one. Let's take a look at this one closely. What time is it? Okay. I got about 10 minutes. All right, so for this one, let me scroll the screen down so you can see the top a little bit better. All right, there's my equation. There's my quadratic equation. Now, do you notice something interesting about this one?
The 4 has a 4 outside of it.
Do you notice what again? Tell me what you noticed.
The 4 outside.
Okay, you notice it from here, but do you notice something from the original equation? Did you know, where did they get the 4 from? That's on the outside of the parentheses, where did it come from?
4 gets $1.
So you have to do that. If you have an equation and you can see that a number divides into all of them, you have to divide that number out first before you can do any factoring. So they divided everything by what?
4
And where did they put that 4?
outside.
Right there. Don't do anything else with it. Leave it right where it is. So now, put it to the side. So they just stuck it to the side. What are we gonna work with?
The 12, we got to find our factors.
Yep, we got x squared plus 7x plus 12. We're gonna work with that 12. Leave the 4 sitting where it is, ignore it for a few moments. I need all the factors of what?
12.
12. So what do I need?
1 to 2.
+1 and a +12?
Yes.
Okay, what else?
5 and 4.
3 and 4, and what else? And 2 and 6. Alrighty. Which ones add up to be 7? Alrighty. So you can see they picked 3 and 4 also. Set them equal to
0.
0. What's my answer? What are my solutions?
-3 and -4.
Okay. Can you see it? Can you see that they skipped the step that I usually put? And you see where they just actually put my solution, they didn't actually show me where they did the math, each part right here?
Yeah.
But do you know how to do that without that step?
Yes.
Just checking. Is that step required? Do you have to show me where you subtracted 4 from both sides and got your solution? No. Just making sure you understand how you got it. Alright, so again, we came up with the same solutions that they have. Alrighty, questions? So when do you factor a number out of everything? When you know you see something that you can factor. So for example, if I had 2x squared plus 16x plus 22. Can I factor something out before I actually do any math? Yes, I can. What should I factor out?
2.
A 2. So your goal is to look for that if you see it. If all of these numbers are even, you know you can factor something out. Okay?
So when you get the answers, what's happening to the 4?
You don't do anything with the 4. They just want to know what number can I plug in for x that's going to make this whole thing equal to 0. The 4, you don't care what happens to the 4. You just want to know what numbers can I plug into x that's going to make that whole thing equal to 0. And the answers are -3 and -4. Yes. What if there is nothing that you can divide? Good question, because that'll come up next. Alrighty, so let's see what the next slide looks like. Alrighty, here we go. Next slide. Now, they're using, again, what you see on the screen is missing a couple of steps. So let me actually give you all the steps that you need for this. We're going to do something here called swing and divide. And then we'll go. All right, swing and divide. They usually call it factor by grouping, but I like swing and divide better. All right, have you heard of swing and divide before?
No.
Okay, so let's do this one. Here we go. I've got 3x squared plus 7x minus 6. That's a minus 6 equals 0. All right, swing, then divide. Swing means take the number in the front and swing it. When you swing, you multiply. So swing means multiply. Can you see swing? And I'm putting a multiplication sign there. Swing and multiply. Alrighty, so when I swing the 3, it ain't gonna be where it is no more. It's not there anymore. So now that I swung it, I have x squared plus 7x. I swung and multiplied. What should I have right here now?
18.
Negative or positive?
Negative.
Negative 18. Now go back and do what you learned to do with the factoring. What did we learn to do with factoring from over here on this screen right here? What did we find out? All the numbers that multiply together to give me what?
18, but add -7.
In this case, I want negative 18. So, tell me the numbers that multiply together to give me negative 18.
Positive 1.
Okay, positive 1 and,
-18.
okay, positive 2 and, negative 9, positive 3 and,
6.
negative 6. Okay, am I done? No,
No.
swap the negative signs. Negative 1 and positive 18, negative 2 and positive 9, negative 3 and positive 6. Now, out of all of these numbers, which ones add together and become 7? Positive 9 and negative 2?
Yeah.
All righty. There we go. We're good? Put your two sets of parentheses like we always do. So I should put what?
X minus 2.
X minus 2,
X plus 9.
x plus 9. Now you got your divide. We just swung, we didn't divide. This is called swing and what? Swing and divide. So once you get down to this step, you got to divide. So you should put yourself a little note here. Right here is where you divide. Divide by what? Well, what did you swing? The 3. So we divide by 3. What did you swing? We swung the 3. So now divide by 3 here and divide by 3 here. All right, we're good? Now simplify if you can. Can I simplify 2/3 or is 2/3 already simplified? Okay, what about 9 divided by 3?
Yes.
What should I get? 3. Can I set both of these equal to 0? Of course you can. Set this x minus 2/3 equal to 0. Set x plus 3 equal to 0. What's my solutions?
X plus 2/3.
Yeah.
2/3.
X equals
X equals
2/3. And then X.
There you go. So again, I can add 2/3 to both sides, showing you this step. So now that cancels. So x equals positive 2/3. And over here, I'm going to subtract 3 from both sides. So x is equal to 3.
So what, to prove it's true, do you plug the positive 3 into the original equation or the one that we swung?
You plug it into the original equation. Because you swinging and divide just helps us figure out how to get to the solution. So when you want to check it, plug this into the original equation. Got it?
Yes.
Okay?
What's the purpose of this method?
This method is when you cannot, like, so when you looked at the original equations, you had a number in the front of the x squared. And there's nothing that divides into 3, 7, and 6. Remember the previous one, we had all those even numbers, so you could divide by 2. This one, they will have nothing, all 3 of them will not have anything in common. The 3 and the 6 do, but the 7 don't. So you use this method when all three of these numbers are different, and you have to have a number in the front over here of this x squared. Can't be a 1, it's gotta be a 2, 5, 15, whatever it is. There has to be a number to the left of the x squared. And when you do swing and divide, you can see that 18 has two numbers that add together to give you 7. Now, are you gonna have some that you can't do swing and divide? Yes. And that's when we come to the quadratic formula, which we will do next time when you come in here.
What's that method called, the factor out, the GCF?
Factoring out the GCF, or you're looking for the factors, not just the greatest common factors, you're looking for factors. All of the factors, not just any particular two. So we'll finish this where you'll actually practice a couple of these methods when you come back.
When will, we get our
When will we get our,
study guide?
you will get your study guide, probably end of next week. Let me hit the stop button here.